The tornado outbreak associated with Hurricane Milton will go down as the largest tornado outbreak on record in state of Florida history. More than 40 tornadoes crossed across the state, across central and southern portions of the peninsula. I'm meteorologist Nick Stewart. Will take a bit of a deep dive into the meteorology behind this event. What exactly was the environment that led this to be such an outlier? We'll be using reanalysis data as well as some of the observed data as well to kind of break down exactly what led to this historic event. So the original parts of this research were recently presented at the Central Iowa NWA conference. That was back in late March of 2025. First and foremost, Hurricane Milton, it did peak at Category 5 strength, did get sub 900 millibars, got down all the way down to 897 millibars, peak winds at 180 miles per hour. It did weaken before landfall. It was a Category 3 at landfall. We had sustained winds over 90 miles per hour in Venice, Florida, with gusts over 100 miles per hour, also in Venice, as well as Sarasota. It will also go down as the 9th costliest U.S. hurricane on record, more than $34 billion in damage. We have an instrument here at the Kennedy Space Center called the Tropospheric Doppler Radar Wind Profiler. It takes a snapshot of the wind environment in the lower troposphere every 5 minutes from about 2 kilometers to 20 kilometers. And here's that data. What's really neat about this is the eye of Milton crossed right over the site. You can see it there around 8 Zulu. Pretty much made landfall, or more so crossed the T-Drip site right around 8 Zulu. It's about 4 a.m. local time. And if we kind of loosen out some of the data, we flip the axis, and what we can actually create is a bit of a cross section. So you can kind of see the actual cross section of Hurricane Milton throughout the day over the area. But you'll really notice on the eastern side of the storm some pretty high-end wind shear. You had winds around 2 kilometers off the ground, over 50 knots, and then higher up you had much stronger winds approaching 80 knots, around 7 to 8 kilometers up. So of course that's turning with height as well. You got great wind shear, both direction and wind related wind shear there. So again, Milton will go down as the largest tornado outbreak on state record. There were 3 EF3 tornadoes. And when you look at all tropical tornadoes associated with a landfalling tropical system across the entire United States since 1995, there were only 8. And 3 of them happened with Hurricane Milton. We had 6 EF2 tornadoes, and unfortunately there were 6 fatalities with the Fort Pierce EF3. That will also be the deadliest tropical twister since at least 1995, when I have good records. Here's a look at the Fort Pierce tornado. Again, this will be one of the major tornadoes and the deadliest tornado of this event. A tremendous amount of debris as this was moving into the south side of Fort Pierce, right by the airport there. This originally formed over I-95 before crossing northeastward. And again, you can just see a tremendous amount of debris before it really turns into a big wedge tornado. At this point in time, it was getting a little close for comfort, so we made the decision to head north to kind of get out of its path. And this is when I think it was at its peak intensity. Very loud tornado. Incredibly strong motion with it.
Listen to the roar.
And chasing this day, one thing that we really had to realize that a lot of these tornadoes were including northwest, and that's kind of where we were in relation to that tornado, so we kind of had to get the heck out of there. So the top 5 tornado outbreaks on state record, Milton there at 46 tornadoes, that's almost double the previous record holder of Debbie in 2012 with 24 tornadoes. We had Irma in 2017 at 23, as well as tornado outbreak in 1997 at 23, and then at 19 tornadoes, a tornado outbreak in 1979. But 3 of the top 5 tornado outbreaks were associated with landfalling tropical systems. Nearly all of Hurricane Milton's tornadoes were in that right front quadrant that's relative to the storm's motion. So it's not always, right front if it's moving this way, but if it's moving that way, it's related to the storm's motion. And there is a lot of research out there that indicates that the helicity in that right quadrant is up to 4 times stronger than the left quadrant, especially in these more sheared hurricanes. That's kind of what was happening as Hurricane Milton was getting close to landfall. When you look at the reanalysis data, you got ML Cape, mixed layer Cape there on the left, you got the 0 to 1 kilometer SRH, storm relative helicity on the right there. And you can see this overlap of a pretty intense thermodynamic and kinematic environment there. You had mixed layer capes pushing over 1,000 across the central and southern peninsula. And over that, you had 0 to 1 kilometer storm relative helicity, well over 300 to 400 in many cases. So a very high shear as well as high cape environment setting up relative to Florida standards. The Storm Prediction Center, you can see they issued just one big tornado watch across the state of Florida, and you can see all the tornado warnings and tornado reports as that system moved on northward. And you can also notice that big area of dry air, kind of drier air pushing into the eastern quadrant. And that really helped lead to a lot of the tornadoes, which we'll talk about here in just a moment. Some more videos. This is that Fort Pierce tornado as it crossed over I-95. You can see this is from one of the rest stops there. Thankfully, you know, we had this hurricane ongoing because there was not a lot of traffic there. You can see the rest stop was pretty empty at this point in time. So not a whole lot of traffic there on the interstate. It's very easy to travel around when storm chasing. And you can actually see some of the same debris that I was filming, that big tarp that are being ripped up in the sky. The tornado actually did hit one of the cameras right on Interstate 95. Here's a view there. Pardon if you're a little motion sickness. But again, this is as it was basically impacting the tornado there, and then we kind of lost it right as the core of the tornado was passing on through. So when it comes to the methodology of what we're going to be doing here, we're going to be collecting all the tornadoes from 1995 to 2023. That is courtesy of the Storm Prediction Center Tropical Cyclones Tornado page. You can find that over on the SPC site. We're going to run in a reanalysis using ERA5 data, and we're going to be using MetPy as the calculator for all of our severe weather parameters here. And then we're also going to be using the bunkers storm motion parameter, the calculation there for storm motions. That's how we're going to derive our storm relative helicity values for this event. We're using the 1995 to 2024 data set, not only because the Storm Prediction Center has it, but we didn't want to add to it simply because at times it can be very difficult to separate tornado and hurricane damage if you don't have good radar data. And there are some great studies from McCall and Agee from 1987 and 2011. Ironically, one was talking about the wish they had better radar data, and then the one in 2011 talked about how much the radar data helped basically see these tornadoes, where we're actually seeing more tornadoes. The WSR 88D network basically doubled the number of tornadoes being detected in these tropical systems. And part of the reason, if you look on the right there, you can see two different images. One of those is tornado damage, EF2 damage. One of those was hurricane damage. Just looking at that, can you tell right away? Because I really can't. But you can see there. One of them, the top one was EF2 damage. One of those was wind damage. Look very similar. And prior to good radar data, they might have all just been considered hurricane damage. But now that we have these higher resolution radars, we can actually better separate that. And that's why we're using that data set from 1995. And that's when those WSR 88Ds were fully implemented across the state of Florida. ERA5 data, it's a bit of a coarser resolution at a 31 kilometer grid, but it does perform well in terms of convective parameters. There's a lot of studies that do indicate that. You can see some of the diagrams there from a paper back in 2021 talking about the correlations compared to observed soundings with ML Cape, LCL height, as well as 0 to 1 kilometer SRH. And you kind of have all of those correlations somewhere in the ballpark of 0.8 to 0.9. So for our purposes, I think they'll be pretty good. And compared to any other reanalysis softwares, this works pretty darn good. So here are all of your tropical tornadoes. So all tornadoes in the state of Florida associated with a landfalling tropical event. And I kind of drew a bit of a trend line there just to kind of see that. You have on the y-axis is 700 to 500 millibar mean relative humidity. On the bottom axis there, the x-axis, you have mixed layer cape. And what I'm really kind of showing here is that if you have some mid-level dry air, you're going to start trending towards higher instability levels. And that just kind of makes sense, right? And when you throw in the Milton tornadoes there, so just seeing how Milton stacks up here, you can kind of see how Milton was kind of sitting below that trend line for mean relative helicity. And overall, I think that's going to be a pretty major player as to how this entire event evolved. And so when you look at that mid-level dry air intrusion, there it is kind of reanalyzed there with ERA5. You had a big kick there of dry air early in the day and then through the afternoon. We had that relative humidity value sub about 70%. And when you look at the the tornado count on the first primary y-axis here, this is Hurricane Milton, and you had the peak mean relative humidity around the mid-levels somewhere around like 40 to 60%, kind of in that area, where the other climatology show that the peak mean relative humidity is closer to that 70 to 90% range. And so you had this drier mid-level, which I think was a pretty significant role in what led up to how significant this event was. When you have that mid-level dry air, you're going to have more instability, and therefore you're going to have more lightning as well. When you look at the lightning strokes, these are cloud-to-ground lightning strokes from Hurricane Milton to the left compared to Hurricane Irma there on the right. Significant difference there in the number of lightning strikes. More than 8,800 cloud-to-ground lightning strikes with Hurricane Milton on October 9th, where Hurricane Irma, we had just over about 1,100. So a significant difference there, just again showing the difference in the instability there in the portions of the atmosphere. Now we're going to look at, just again, all tropical tornadoes. We have 0 to 1 kilometer storm relative helicity there on the y-axis, mixed layer cape there on the x-axis, and there's your scatter plot of all your different tornadoes there. So a big spread in those tornadoes across the board there. And when you look at, again, just Hurricane Milton, you can see a lot of the Hurricane Milton tornadoes are skewed kind of towards that higher helicity, as well as kind of skewed more towards the higher mixed layer cape. So if we apply a standard deviation to all of this, you can kind of see those Hurricane Milton tornadoes are heavily favoring that upper right quadrant, which is higher shear, higher cape. And so you kind of have this very higher end kinematic and thermodynamic environment setting up with Hurricane Milton compared to other tropical tornado outbreaks associated with landfalling tropical systems. So that in itself, I think, screams a lot for why Milton was not only as expansive as it was in terms of quantity of tornadoes, but also how many of these were on the stronger side of things. So let's take a look not only at the tropical tornadoes, now let's look at just all tornadoes. So these are all tornadoes in the state of Florida between 1995 and 2023. Those are the reason I'm stopping at 2023 is that's the end date for storm data, and that's when all data is finalized, no longer preliminary. 2024 data is still considered preliminary at this point in time, as well as how young we are in 2025. But again, there are all your tornadoes. Again, mixed layer cape on the x-axis, 0 to 1 kilometer storm relative helicity there on the y-axis. And when you saw kind of a bit of a trend line there, just for fun, you can see just how far above all of this Hurricane Milton stands, well beyond the norms here for typical tornadoes. And again, we can apply a standard deviation, and not only for tropical tornadoes, but all tornadoes. And in this case, now we're talking about 0 to 1 kilometer storm relative helicity in excess of 2 to 3 to 3.5 standard deviations above. So that just really shows just how much the kinematic environment here was an outlier compared to other tornado events. And even on the mixed layer cape standpoint, I mean, you only have 2 tornadoes that are sub 0 or negative on the standard deviation. The vast majority of these are positive, with many of them approaching about that 0.5 to 1, a few about 1.5. So again, a very big show here of just how much of an outlier the Hurricane Milton environment was compared to all other tornadic environments in the state of Florida. Throwing on just some other hurricane events just for fun, Hurricane Irma kind of had a similarity in terms of a lot of the tornadoes were higher end for the storm relative helicity as well as mixed layer cape, but there were some on the lower side as well. So unlike Milton, which was pretty heavily favoring that right front quadrant, Irma was a little bit more scattered. A few more thrown on here as well. Hurricane Opal in 1995, those were some of those big outlier points there in storm relative helicity. That was a pretty strong hurricane in the Panhandle region. You can see some of those were 4 to 5 standard deviations above. But the Cape values, not as significant. And then the other one to kind of show there is Tropical Storm Debbie in 2012. That was previously the largest tornado outbreak on record for like a single event there. And you can see how much that's really skewed towards the lower side of all these other hurricane and tropical events, both on not only storm relative helicity, but also on mixed layer Cape. And the helicity makes sense because it's a tropical storm, not a hurricane, so your center of low pressure is not going to be as low compared to the surrounding environment as it would be for a hurricane, so your wind fields are just not going to be that intense. But there's some other similarities. If we move away from the scatter plots, move more towards the box plots, I think this really shows just how much of an outlier Milton was. So on the left there is tropical tornadoes, on the right is going to be all tornadoes. This graphic is looking at mixed layer Cape, and what you can see there for Hurricane Milton, the 25th percentile was basically near the 75th percentile of other tropical tornadoes with mixed layer Cape. And then for even all tornadoes, Milton really favored kind of that maybe 60 to 75th percentile of all tornadoes. And again, that kind of says a lot because you think of just how hot and humid Florida can be. You can get some big Cape sometimes. And so even without those significant numbers of Cape, you can still see Milton is kind of favoring the higher side of things. Storm relative helicity is a really fun one to look at. Again, the left, those are all tropical tornadoes, so those induced by a tropical system. And Milton is outpacing, the 75th percentile there with the 25th percentile. I mean, it's way above that. And all tornadoes, I mean, it's significantly beyond. I mean, the 75th percentile for all tornadoes in climatology, 95 to 2023, is sitting somewhere around, maybe 180 meters squared per second squared, or the 25th percentile for Milton is just shy of 300 meters squared per second squared. The kinematic environment was just extremely high end for Milton compared to climatology, basically. And I wanted to throw this in too because I think this is just really fascinating. One part, of course, is cloud bases. If you have lower LCLs, it's easier to spin up these tornadoes, in theory. And when you look at the LCL heights for tropical tornado events in Florida, I mean, I don't know if you could nail the middle of that box plot any better than this. And so the LCL heights actually fit really well in climatology. So that also kind of tells me there is clearly something else acting here. And again, I think that's where the storm relative helicity and the mixed layer Cape really come into play. And I think it's that mid-level dry air that really had a pretty pronounced impact on things. I want to talk a little bit about the tornadoes themselves. Here's Fort Pierce EF3 tornado. That track again was EF3. It's one of 8 tropical tornadoes since 1995. Peak winds were 155 miles per hour. The track length was 21.2 miles, 500 yards wide. It's a pretty large tornado. And again, unfortunately, there were 6 fatalities with this event as well. It was the deadliest tropical tornado since 1995. You can see the radar view. Here's your supercell, a classic hook right here as it's approaching I-95. The tornado warnings were fantastic. There's your debris ball, crosses right by the airport, and then goes right into northern Fort Pierce towards Vero Beach. And again, that was the EF3 tornado. And you can also notice on this the radar loop all these other little spinners off the coast as well. I mean, you imagine if the coast of Florida extended eastward like another 50 miles, just how many more tornadoes there could have been, just because there were so much. I did want to touch on the lightning as well on this day, just kind of for fun. This is one of the lightning strikes associated with Hurricane Milton, and what you're looking at here is using the Cape Merlin, or the Cape Mesoscale Eastern Range Lightning Information Network. It's a network of 10 lightning sensors across Cape Canaveral Space Force Station and Kennedy Space Center. And you'll notice here on the time, I mean, we're talking thousandths of a second here per frame. And you're actually mapping out this cloud-to-cloud lightning strike as it extends from southwest to northeast. And this just kind of shows just kind of the lightning capabilities, the lightning mapping capabilities we hear at the Cape. Follow along if you're interested in more, a bit of a tease here for more research I'm doing on just lightning in general associated with our thunderstorms. Pretty cool stuff when you can actually map out these lightning strikes in real time. Here it is in real time. You can see how fast the lightning strike actually is there in real time compared to the animation there. There were all lightning data with that Fort Pierce tornado. Clouded ground activity, we did have a big spike right before we had the tornado form there. You can kind of see all these markers here are those clouded ground lightning strikes, and here's the actual path of the tornado. And the black line here, that is the storm track. So using the vertical integrated liquid, the VIL track, and using that center and tracking the storm for the lightning. And we actually did see pretty good lightning jumps with this storm ahead of that EF3 tornado. If you look at the sigma method, basically it's a 10-minute running average of lightning, the 2-minute most recent average. If you jump beyond 2 standard deviation to the previous 8 minutes, that will trigger a lightning jump. And you can see with this supercell, we did trigger a few kind of false alarm lightning jumps early, but then you can really see as the lightning activity ramps up to the total lightning activity is the blue line. You can see we actually do jump twice here above that lightning jump criteria. And so we actually did have an early warning of 9 minutes if you're looking at just the lightning. And again, this was all detected on that Cape Merlin, the mesoscale Easterrain Lightning Information Network. So with all that said, there's some of my contact information. If you want to reach out for more information, there's my Twitter handle there as well, Instagram, Blue Sky, whatever you guys are on. You can follow me on Twitter and Facebook as well. Those are some of the references down below. And if you do want more of a deeper dive into some of the background research, some of the stuff that kind of goes well beyond kind of what I presented here, kind of a background in tornado outbreaks in Florida, the mid-level dry air intrusion and tornado outbreaks associated with landfalling tropical systems. A lot more background. You can find it on the research tab on my website, MidwestWeatherCenter.com. But thank you guys so much for tuning in for this bit of a deep dive. If you're interested in more stuff like this, please let me know. I'm trying to do more and more research as I'm kind of getting more and more capabilities to do this kind of research and analyze and code and kind of pull off some reanalysis. So if you have more events that you might be interested in me looking at, I'd particularly favor those that I'm actually kind of a part of or have actually seen. Let me know. Happy to do them. Otherwise, thank you guys so much for tuning in. Feel free to check out some of my other videos, including my chasing of the Hurricane Milton tornado outbreak. Also, we have Hurricane Debbie, Hurricane Idalia, we had Hurricane Helene. Helene's a really interesting video as well. It gets stranded on I-10 by a bunch of trees. 0 out of 10. Would recommend. Thanks for tuning in, everybody. We'll see you again next time.